Hello, and welcome to our geometry videos. This is Unit 2, number 75. And so, uh, here we're asked to find the area of the shaded triangle. It's surrounded by a rectangle, find the area of the triangle. There's a couple different ways you can do this. I'll kind of give you the hard logical method, and then I'll show you kind of a shortcut that you can use. The hard logical method would be to say, okay, we have this rectangle, so we can find the area of this rectangle, and then I know how to find the area of these right triangles. You know, I just do 1/2 base times height, you know, and 1/2 base times height here. And so we can get those areas of those white triangles relatively easy. So we take the whole triangle, we subtract off those white triangles, and we're left with the shaded one. Okay, that would be like finding the area by subtraction. And sometimes that's a perfectly acceptable method of doing things like that. However, there's one thing we should note about finding the area of a triangle, and that it is 1/2 base times height. So let's write that down so we're all clear about that. But the thing to note is that when we're finding the area of a triangle, we don't have to have it set up like a right triangle. It's nice if it is, because then the base and the height are clearly defined, and we can, you know, use that. One side is our base, the other side is our height. But if the triangle is oblique like this, and that means it's not right, so it's kind of slanted over on its side, it's oblique, we can still use the idea of the base and the height to find the area of this triangle. So this segment of 7 is going to be the base of this triangle. So I'm going to plug in 7 for the base. Now the height, you may be saying, we don't know the height, right? I don't know how tall this triangle is. But we actually do. The height of a triangle originates from the vertex opposite of the base down to the perpendicular of the base. So this side of 8 right here actually is the height of that triangle. And imagine if we took this point of this triangle and kind of just slid it over here, so that now, you know, maybe the shaded region looks something like this. It connects to there and to there. So it's been pushed over to the side. The height hasn't changed. Right? So when you take a triangle and you move it so that it's oblique, and the vertex point there moves from side to side, as long as it's going along parallel with the base there, the height doesn't change. So the height of this shaded triangle is 8. So area equals 1/2 times 7 times 8, which is the same as 1/2 times 56, if you want to do it that way. Typically, if I was doing this, I'd probably just say 1/2 of 8 is 4 and get that, and then just say, well, it's 4 times 7, which is 28. So either 1/2 of 56 or 7 times 4, either way you want to think of it. So the area of this triangle is 28. And the idea that they were trying to get across was this idea of, you know, oblique type triangle, where the height is not going to change as long as you know that it's perpendicular to the base there. If you have any questions about that, feel free to leave a comment. Otherwise, as always, you can like, subscribe, or share our videos.